All right, let's learn about graphing secant. And this is just one method for graphing secant. There is another video that's going to explain a second method for graphing secant, or maybe you've already watched that one, and this is the second one. Okay, so here graphing the secant function, we can use what we learned about the connection with cosine and secant. And so I'm going to use that direct connection by actually graphing the cosine function that corresponds to the secant function, and then making it into the secant function. So no matter what, we always want to put this into standard form. So I'm first going to take my function here, and I'm going to factor out the b, so 1/2, and then I'm going to get x minus, this is going to be 2 pi, and then minus 2. Okay, and so I'm going to go ahead and graph this as its respective cosine function, and then see what that is going to do to my secant function. So let's consider the cosine function. So I'm going to write consider the respective cosine. I'm going to write it as f. F of x is 3 cosine of 1/2 quantity of x minus 2 pi minus 2. All right. And so then I'm going to go ahead and find all the information about this. So find the period, find the amplitude, find the phase shift, find the vertical shift. So my period here is absolute value of 2 pi over b. So absolute value of 2 pi over 1/2 is going to be 4 pi. My amplitude is 3. My phase shift is 2 pi to the right. And my vertical shift is 2 down. All right, and then I can go ahead and I can graph this, but before I do that, I'd want to find my increment. So let's go ahead and find the increment. So increment is going to be the period divided by 4. So that's going to be pi. And then the phase shift. So phase shift is 2 pi. So we're just going to count by pi's. Okay. So you can count by pi's. I'm actually going to stretch this out a little bit, and I'm going to count by pi over 2's, just so that my graph isn't super squishy when I do the secant graph. Okay, you can totally still keep it how it is though. All right, so let's go ahead and graph then this cosecant graph. All right, so let's see, my cosine tells me my amplitude is 3 and my vertical shift is 2 down. So my maximum is going to be 1 and my minimum is going to be -5. So I might want to make sure I know that, keep that up in my mind here, so that my max is 1 and my min is -5. All right, so let me just make my graph a little bit. There we go. Give myself some more space. Okay, so I'm also going to be shifting pi, 2 pi to the right. All right, so and then my period is 4 pi, and I'm going to do that. So I'm just thinking about some things in my head real quick, and I'm going to make this as my graph. I'm going to go ahead and put my y-axis. I'm going to go -5 right here. -5, 4, 3, 2, 1, 0. So here's going to be my x-axis. And then this is going to be 1, 2, 3, and so on. Okay, cool. And I said I'm going to count, I'm going to put my tick mark right here, and I'm going to put every 2 is going to be pi, just so my graph doesn't get super squishy. So label that so everybody knows what we're talking about. That's pi there, and then this is going to be 1. Okay, so each of my tick marks, my little tick marks in here, are going to be pi over 2's. Okay, cool. So graphing then what my sine function would look like. I'm just going to graph that in pink here, and I'm going to have my first point. Finding my first point, let's go ahead and do that. So the first point here, when you calculate that first point, we're going to take, normally our cosine function is at 0, 1. So that first point here transforms to, I'm going to do 0 times 1/2 plus 2 pi. So it's going to be at 2 pi. My y-coordinate, 1 times 3 is 3 minus 2 is 1. So I'm going to be at 2 pi, 1 is my first point. All right, so 2 pi, 1. Go ahead and graph that. 1 pi, 2 pi, 1. So you can kind of see why I stretched it out a little bit. That's my first point. My period is 4 pi. So I'm going to go 4 pi from there. 1, 2, 3, 4 pi. I'm going to be here. Halfway between there, I'm at my minimum value, which is -5. Halfway between the first half, I'm at my midline. So my midline here is going to be at -2. And that's halfway between, and there we go. So I'm going to make this dashed. I don't want to make it solid because it's not the answer to my question. So I'm going to make that dashed. If you want to do another period, you could. I'm just going to leave that there for now. So that is just by thinking about what my cosine function is that I already know how to graph. So graphing that, then, I can go ahead and transform that into my secant. So what we learned is that the secant asymptotes are going to be at the midline values for the cosine function. So that means I'm going to have an asymptote right here. I'm just going to make it solid highlighter. You can use highlighter, you can use a dash line, that's fine. I'm going to have another asymptote right here. Okay. And if I want my third asymptote, you can go in either direction for that third asymptote, or you could just do your period like this. Then my secant graph, I'm going to have this, whoops, wrong color. I want my blue. So this maximum point from the cosine function is going to become my minimum for my secant graph. This minimum point down here for the cosine function is going to become my maximum. And then this maximum is going to become my minimum. So I know that I have those three values on my graph, so I can go ahead and label those. And so this point here is 1, 2, 3, 4 pi, -5. And then this one here is 6 pi 1. And then here I have 2 pi 1. And oh, I forgot to label my asymptotes. So in here, labeling my asymptotes, I have x equals, this one is at 3 pi, x equals 4. Wait. 1 pi, 2 pi, yeah, 3 pi, 4 pi, yeah, x equals 4 pi. 1, 2, 3, 4, 5 pi, not 4 pi, that's a 5 pi. Can't count today. Okay. And so the other thing that I want you guys to do is I want you to find a sixth a sixth critical value. So for a cosecant and a secant function, you are always going to graph 3 asymptotes and you're going to graph 3 points. Okay, so we're going to find additional within one period. So I'm going to find an additional point here. So if I think about a cosecant graph and a parent function for cosecant. So let's do an additional point. And I think about a parent function point. That's an easy one to work with for secant. Well, that would be not using a √3 or a √2 in the y value would be nice. So I'm going to use the point. If I plug in pi over 3, then my secant value is 2. And so let's just transform where that goes. So pi over 3 comma 2, where does that land? Well, my x's, what am I going to do to it? My x's, I multiply by 1/2, and then I add 2 pi. So I take my pi over 3, I'm going to multiply by 1/2 times 1/2 plus 2 pi, and I can get my new x coordinate. So my new x coordinate is going to be pi over 6 plus 2 pi. So that's 2 and 1/6. So that's 13 over 6. 13 pi over 6. And my y coordinate I have as a 2. And for my y coordinates, what am I going to do? Well, I am going to multiply by 3, and I'm going to subtract 2. So 2 times 3 is 6, minus 2 is 4. So I have 13 pi over 6, comma 4. Now, you don't have to land this one on a graph line. So this is okay, not on graph line. Put that, okay, not on graph line. Okay, so 13 pi over 6, we just need to think about what that represents. So that is 2 and 1/6, so it's just a little bit past 2 pi. And then that y coordinate is at 4. So just a little bit past 2 pi, so 1 pi, 2 pi, a little bit past there, and my y coordinate is up at 4. So 1, 2, 3, 4. There I'm going to have my point. I also know that I'm going to have the symmetry for that point. So here, kind of a little bit before the 4 pi, and then that's 1, 2, 3 units. So 1, 2, so about right here, a little bit before right there. And then I'm going to have that point also right there. And I'm going to also have that point right there. And so I can see here that there is going to be my graph, and here is going to be my graph. And there's going to be my graph. So here we have this other additional point is 13 pi over 6, comma 4. And you that one, you don't need to label the others, you can just dot them. And then I'm going to continue this to make another asymptote. So I'd have my other asymptote here at pi. I'd also have my next asymptote at negative pi, and you would graph as much as you need. So we'd have the other symmetry point here, just like that. And then I can do the same here and graphing my points accordingly. And making as much of the graph as you need. And so here I have 1 full period. So this is representing 1 full period between these asymptotes. Okay, and then I have an additional kind of 3/4 of a period in here. And there's the graph for g of x equals 3 secant of 1/2 x minus pi minus 2.